Alright, in this video we're going to talk about Unit 7, Objective 2, Day 2, the in-out problem. So this kind of builds off the accumulation function that we looked at yesterday, except this is going to be a special problem where you're going to have two different rates acting against each other. So one rate's going to be increasing and the other rate's going to be decreasing a certain amount. So you might be filling a bucket with water, but the bucket has a hole in it, so water is leaking out the bottom. So you're putting water in and taking water out at the same time. So there's three ways that we can look at the in-out problem. So the first one is just talking about the total rate of change. So in this scenario, we're going to call A of t the amount of stuff that we have inside the bucket or the pool or whatever. The amount of stuff that we have, we're going to call A of t. Now, oftentimes in these problems, just like the accumulation function problems, the function that you're given is going to be a rate. So we're going to call I of t the rate at which stuff is going in. We're going to call O of t the rate of stuff going out. So the total rate of change for the amount of stuff, A prime, is just going to be the rate of change going in minus the rate of change coming out. So I minus O. Remember, I and O are rates, so we don't have to say I prime. I is already a rate. So A prime equals I minus O. Now, coming from that, we can look at the total amount that we have. So not how is this stuff changing, but how much stuff do we have? And that's going to relate to the accumulation function in the same exact way to the fundamental theorem of calculus. So we're going to have to say the initial amount, A of A, plus the integral from A to B of I of t minus O of t. So we have to take the integral of the rate, so the integral of the rate of change is going to give us the total net change, and then we have to add the initial value. So it's just like the accumulation problem, except now the rate that we're taking the integral of is a difference of rates. Now, one thing that AP tends to ask that's a little bit different with the in-out problems is they oftentimes ask you to come up with an equation that will tell you the amount of stuff that you have at any given time. So the difference between part 2 and part 3 of the in-out problem is part 2 is asking for how much stuff do you have when t equals 7. Part 3 is going to be asking, give me an equation that will give me the amount of stuff that I have at any time. So instead of actually finding that integral from a to b of I of t minus O of t, we're going to change the upper limit to t. So we can plug in any value that we want. The thing to be careful of, though, is if we make our upper limit of integration a variable, we're going to need to make sure that the variable inside the integral is different. So you'll notice that it's A of A plus the integral from A to t of I of x minus O of x dx instead of I of t minus O of t. So those are the three things that are going to come up with the in-out problem. So let's look at an example of an AP problem. Alright, so we have water being pumped into an underground tank at a constant rate of 8 gallons per minute, water leaking out of the tank at a rate of radical t plus 1 gallons per minute for the first 120 minutes. At time t of 0, the tank contains 30 gallons of water. So there's some important stuff that we need to think about before we even jump into this problem. So the first thing is we are pumped into the tank at a constant rate of 8 gallons per minute. So that tells us that I of t, the rate at which we are being put in, is 8. Then if we keep reading on, water leaks out at a rate, so out at the rate of radical t plus 1, so we know O of t is going to be the square root of t plus 1. And then it says at time t equals 0, 30 gallons of water are in the tank. So that tells us that A of 0, our initial value, is equal to 30. So as we're going through this part A, how many gallons of water leak out of the tank from 0 to 3? So this is just a plain accumulation problem. This isn't the in-out part of this question. They just want to know the amount we leak out, how many gallons. So we have gallons here, and we have gallons per minute here. So to get rid of the per minute part, we integrate. So this is just an accumulation function. You're given a rate. You want to know the total change in the antiderivative. Now notice, it also doesn't ask how many gallons are in the tank. It just wants to know how many have leaked out. So we don't have to worry about an initial value here. We just have to find the integral from 0 to 3 of the square root of t plus 1. Well, we have chain rule, so that's a u substitution. So u is going to be t plus 1. du is going to be dt. Our upper limit is going to be 3 plus 1 is 4. Our lower limit is going to be 0 plus 1 is 1. So we can rewrite this integral as 0, not 0, from 1, from 1 to 4, not 0 to 4, but 1 to 4 of u to the 1/2 du, which is going to equal 2/3 u to the 3/2 from 1 to 4, which is 2/3 times 4 to the 3/2 power minus 1 to the 3/2 power. And this is a no calculator question. So if you don't feel comfortable simplifying, we could put this into a calculator, which means we can stop now. As long as you get to a spot where you can put this into a scientific calculator and get an answer, we can stop. Algebraically equivalent, we can stop here. Now, if we were to keep going, we're going to get 2/3 times. The 3/2 power means take the square root, that's the denominator tells us the root, and then raise it to the 3rd power. So the square root of 4 is 2, to the 3rd power is 8. 1 to the 3/2 is just going to be 1. So we have 8 minus 1 is 7. 7 times 2/3 is going to be 14/3. So how many gallons? We have 14/3 gallons that have leaked out. So that's part A, just a very straightforward accumulation function. How much water accumulated as it leaked out of the tank. Now part B is asking us how many gallons of water are in the tank. So if we think about this, now these two rates are acting against each other, and we want to know how much is left inside the tank. So this is going to be scenario number 2. So we're thinking about the amounts being equal to the initial value plus the integral from 0 to 3 of I of t minus O of t dt. So this is how we're thinking about this problem. So the amount that we have, so we're going to call that A of 3, the amounts that we have at t equals 3, is going to be A of 0, our initial value, 30, plus the integral from 0 to 3 of I of t, well, we said I of t is equal to 8, minus O of t, well, we said O of t was the square root of t plus 1 with respect to t. Now, we know from earlier that this is going to need a u substitution, but that u is going to mess up with this 8. So what we actually want to do here is split this up into 2 separate integrals. We already know from earlier that this value here is 14/3. So really all we have to think about is integrating this. The antiderivative of 8 is 8t, evaluated from 0 to 3. So we're going to say 30 plus 24, right? 8 times 3 is 24, 8 times 0 is 0, minus 14/3. And we could stop there. If you didn't get 14/3 from before, and you still had that long drawn out 2/3 times 4 to the 3/2 minus 1 to the 3/2, you can substitute that in here for this 14/3 and you're still going to be correct. If you keep going though, we're going to get 54 minus 14/3, which is going to be equal to 162/3 minus 14/3, which would equal 148/3. and then gallons, so let's go ahead and put our units of measure in there. 148 thirds gallons. But again, you can stop here and not worry about your common denominators, especially since this is a no calculator question. So let's look at part C. Write an expression for A of t, the total number of gallons of water in the tank at time t. So this is that third part for the in-out problem. So we need to think about this being A of t is going to be equal to the initial plus some integral where t is our limit of integration, and then x is the variable inside. So we can say A of t is going to be equal to our initial value, we know is 30, plus the integral of our rate of change, so from 0 to t of 8, not plus, but minus, the square root of x plus 1 dx. Oops. And that's it. It doesn't tell us to solve anything. It just says write an expression. We wrote the expression. Again, the thing to remember is if we have a t here, these need to be x's down here. And that's it. That's all we have for this question. There was a part D that deals with the first part of the in-out problem, but we'll look at those in class. So that'll do it for this video. We will see you in the next one.